Today we're going to talk about nomenclature of hydrocarbons and alcohols. We have looked at naming and writing formulas for inorganic compounds, but not the ones that are carbon-based, these organic compounds. And we're going to have our first introduction into what are called functional groups. Now, there are four different kinds of compounds that we're going to look at being able to write formulas for. We need to know how to write these formulas because very often AP asks for us to write combustion reactions using these compounds. And if we don't know how to write their formulas, we can't write the equation for it. So if you'll look at what we've got here, we've got four different compounds. We have the alkanes, and if you look at what their structure looks like, these are hydrocarbons because they contain only hydrogen and carbon. And every bond in this alkane is a single bond. Well, we also then look at alkenes, and when we see the ending "ene" on a compound, we know that somewhere in that compound there's a double bond. That shows up right here. Alkynes, as soon as we see an ending of "ine" on one of these compounds, we know somewhere in that particular compound there's a triple bond. And finally, alcohols have the functional group OH. Now, if you have an OH attached to a metal, you have a base. But an OH attached to a hydrocarbon group is an alcohol of some kind. So how do we name these? Look at the general formula up here. The general formula tells you how many of each of these elements we have based on the name. Anes have a general formula of 2n plus 2 times the number of carbon atoms. So 2 times the number of carbon atoms plus 2, that's how many hydrogens there are in that particular compound. For alkenes, if we know how many carbons there are, we simply multiply that by 2 to get the number of hydrogens. For alkynes, if we know that there are a certain number of carbons, we simply multiply that by 2 and subtract 2 to get the number of hydrogens. And finally, for alcohols, we have, for a certain number of carbons, a number of hydrogens equal to 2n plus 1, and then we simply attach OH to the end of that. Now, we have to be familiar with prefixes as well, and here are the prefixes for our organic compounds. Meth stands for 1, eth for 2, prop for 3, but for 4. The rest of them are common prefixes: pent, hex, hept, oct, non, and dec. However, meth, eth, prop, but, meth, eth, prop, but. You just need to say that over and over until you have that in order and know that those stand for 1, 2, 3, 4 respectively. So let's say that I have the compound propane. Propane tells me that I'm dealing with an alkane. I know it's going to start with C. They all do. Now I need to know how many carbons there are, and the prop tells me, as you look up here in the chart, prop tells me that I have 3 carbons. Now if you go back further up in the chart above that, you'll see that for an alkane, the formula is 2n plus 2. So to come up with the number of hydrogens in that compound, I'll simply take 2 times 3, which is 6, plus 2, which is 8. So there's the formula for propane, C3H8. Heptanol. First of all, by seeing that it is a type of alcohol, I could call it heptanol or heptyl alcohol. You'll still see that sometimes. The newer name is heptanol. But I know it starts with a C, and I know that since it's hept at the beginning, there are 7 carbons. Now, the fact that it ends in "ol" tells me it's an alcohol, and look back up at the formula for an alcohol. It's CnH2n plus 1, so my hydrogens in here are going to be 2 times 7, which is 14, plus 1, which is 15, and then the formula says just put OH on the end. Butene, seeing the end of that tells me it's an alkene. But tells me there's 4 carbons. And the formula for an alkene, remember, is just simply 2n. So the number of hydrogens I have here is 8 for that alkene compound. Finally, hexine. I know that it's carbon, and I know since it starts with hex, there are 6 of them. And since it is an alkyne, the formula is 2n minus 2 for the hydrogen. So 2n is 12, minus 2 is 10. So that's the formula for hexine, C6H10.